to talk about the VISION House Seattle Cascades. For about 15 years, Green Builder Media has been doing demonstration projects of all different kinds and types and sizes and all different geographies. And each project is unique and special for its climate zone, for its location, for the types of problems that we try to solve for. The project that we're going to talk about today, the VISION House Seattle Cascades, is particularly special and unique for a variety of reasons. First of all, because of the project partners that we have the good fortune to work with, and I'll introduce them in just a moment. But also because this project, as you'll hear, is off-grid and net zero with respect to energy, water, and sewer. And so we have a unique set of opportunities and challenges that we are solving for with sustainable design, with green building, with building science practices, and also with the most cutting edge and advanced products and systems and technologies available on the market today. You'll hear a lot more about all of those. With that said, we also want to try to accomplish everything at an affordable or attainable price point that is cost effective, not just for the homeowner, which is CR Herro, but also to create a template that can be replicated in locations and municipalities and in projects across the country. So first, I'd like to recognize our sponsors of this project. And those include Whirlpool, Uponor, Western Window Systems, Boral Roofing, Cultured Stone, Premier Sips, Schott, Rheem, Square D by Schneider Electric, Control4, Panasonic and Panasonic Solar, and Moisture Shield. You'll hear more about some of the products and systems from those folks that we're using in the project throughout the course of today's webinar. And now I'd like to introduce our project partners and the presenters of today's webinar. First, CR Herro, who really needs no introduction, but CR, if you're not familiar with him, he is the VP of Innovation for Meritage Homes, the 7th largest home builder in the country. But he's considered to be one of the most advanced thinkers in the building industry with a 25-year history of industry disruption and new business development for multi-billion-dollar construction industry businesses. So he's run business development and M&A for companies like Vulcan Materials and Lafarge. And now, as I said, he has been incredibly instrumental at Meritage Homes and within his peer set of the production builders in really advancing green building and building science and sustainable products and technology adoption within the production builder sector. I would also like to introduce Stace McGee, who is our designer for the VISION House Seattle Cascades. Stace also has a bit of an illustrious career in the sustainable design sector. He's been helping clients design their dream homes and buildings for over 20 years. He uses his expertise in building science to integrate systems and enduring buildings that perform to their maximum potential. He founded Environmental Dynamics, Inc., which is an internationally acclaimed architecture firm that provides services to clients in the US, Caribbean, and Asian markets. And now he also recently started a design firm called Equiterra. Both CR and Stace are two of our favorite people in the building industry. They've just been a delight to work with. We work with Stace as often as we can as our designer on our VISION House projects. He's now worked with us on several projects, and while this is our first project with CR, he's been a friend for over a decade, and certainly won't be our last project with him. So with that, I'm going to hand things over, CR, to you, and please take it away.
Great. So good afternoon, everybody. I wanted to start this presentation with a little philosophy. And I think any project, it's important to be clear what your intentions are and what are you trying to accomplish that creates value for the industry, that creates value for the homeowner, that establishes something worthy of being done. And so, I wanted to kind of preface this whole discussion with Stace and I with this picture. The little kid on the right is me, and that's my mom, and the little kid on the left is my sister. And this whole project started way back here. This is us in a lake in Michigan that happens to be at my grandparents' house. And my grandparents' house is that special thing from my childhood where a lot of great memories were made, where I grew up, where I kind of learned a lot of life lessons. I used to spend summers there working. And it was a really special house. And when my grandparents passed, I took the opportunity to remember them and bought a parcel of property in the woods near some water that reminded me of that special time in my life growing up and spending time with my grandparents at their house off the lake. And this house really starts with the intention to create something that, as a building scientist that's been in the industry for 20 years, that sets a standard for what I believe in, that sets a standard for availability that can be used to inspire 36-year-old moms living in the suburban area, that they should expect more from their dwellings and their living spaces than has been provided for the last 100 years. And so it was really intended to create a flag in the ground, to create value, to integrate innovation seamlessly into lifestyle, and to demonstrate as a project, as a vision home, what all these partners believe sets an example for the way homes should be built going forward. And when I brought this to Green Builder Media and Stace and explained, not only did I want to build something that extended this experience I had in my childhood for a really significant place to live and to have a family, but also to create value for the industry and to apply all of our expertise and all of our partners' expertise going forward, we were able to reach out and build a consortium with one simple qualification. What is it that we would build for our families? What is it that we would build for our own personal home? What do we stand for as experts in the industry that we believe should be a new standard for the way each of these experts go to the market with their perspective and their source of expertise? And from that philosophical intentions, we've gathered this amazing team of people that have all added to the story and the design and the intentions and the possibilities into a way that, as we walk through this, I am so excited to see it take shape and to be converted from a great collection of best practices to an example home that is living, breathing, and available to demonstrate the results of all this thought. But the information, not only philosophically that's necessary, I want Stace to spend some time walking through, which is great. We want to build something that is good for the people we care about and sets an example, but why?
Hey, CR, I just want to say one quick thing there on that last slide is, and just to emphasize that we very much work as a team, and it takes a team to get done what we need to do to try to bring this project to its greatest and highest potential. And we really enjoy all the team members that we are working with, and that they are the ones that make possible what we're doing now in being able to achieve better buildings in the future. So next slide, if you would, please. So as Sarah's been saying, I've been practicing sustainable, site-specific, climate-driven architecture for a couple of decades. And the biggest challenge that we are coming up with over and over again right now is the erratic climate that we all are living in. And it doesn't mean that it's just all getting hotter. It means that we're having more extreme weather patterns. And we've seen this by all the fires and the drought that's happening in California and up and down the West Coast. We are seeing this with some of the biggest hurricanes geographically in size that we have ever seen. You can see on the image on your screen, that was one of the hurricanes that, thank God, did not hit the United States of America this year. It didn't actually make landfall, but you can see that the eye of that storm is like the size of North Carolina and South Carolina combined. And if a Category 5 storm hit that was that large, what would be the impact? We also are working very much with the understanding that we're really starting to seriously deplete the resources that we have to build buildings with. So we are trying to, in this project, use all of the resources as responsibly as we can. We are trying to understand, with the extreme weather patterns that are happening, what can we do to slightly modify our design to meet the challenges and goals that we have. And as Sarah and Sierra were saying in the beginning, we're also very much trying to understand how do we do this in a physically responsible way, that we don't have big cost overruns or big cost increases, trying to have a more resilient building.
And to underscore that, you know, when we think about responsibility as experts, one of the things that I've become aware of is that the people on this call, the people involved with this project, may make more sophisticated decisions, may understand value broader, may understand material choices more sophisticated than the average consumer. And the thought experiment includes all of that innovation, but inserts a buyer that isn't necessarily sensitive to the technology, isn't necessarily sensitive to the impact of changing climate conditions. And so when I think about this, I think about, honestly, my grandma, right? That she's somebody I care about. She's somebody that I'd want a healthy home. I'd want a comfortable home. I'd want it to be intuitive and easy to use, and isn't, you know, we've all seen examples of incredibly sophisticated homes that require 3 or 4 PhDs in order to operate. And so, you know, we wanted to take all of the features and the design components of a really well-built home, but challenge ourselves to make it usable and of an easy, transparent value proposition that the average consumer can understand. And so our proposition is one of, you know, a responsibility as experts to leverage the potential of technology and materials to drastically improve the form and function of a home, but to make it accessible, to make it something that inspires consumers at the fundamental level to make better decisions when they buy or upgrade their current homes.
I would also say that with some of our partners such as Control4 and Panasonic, that we really are excited about our ability to be able to keep it simple and intuitive for being able to operate and maintain this project.
Right. So as we'll walk through this, the guiding principles of what we think that intersection of technology and usability are, right? We definitely want to look at efficiencies, and as Sarah pointed out, we're going well beyond, you know, conventionally grid-tied services. And even though there's utilities adjacent to the property boundary, we very purposely wanted to build this off-grid, off-water services, off-sewer systems, and not as an example of off-grid living, but because it forces us to create cost-effective measures in a way that optimize the functionality of the house that can't depend on those surge resources that you can plug into. And in doing so, we believe the best practices make it very efficient and effective to tie back into a grid. One of the key principles that we're evolving into around energy efficiency is that if we can eliminate these oscillating demands into the electric grid, into the gas grid, into the sewer grid, into the water grid, it can be much more cost effective and function at a much higher level through that consistency. And that consistency is really driven by forcing the design and the controls for the design off grid, where you have to manage your loads and your controls for your loads very, very clearly. So efficiency, being reproducible. We wanted to make sure everything we chose for this home was shovel ready. and capable of being applied in multiple climate zones across the country and outside the U.S., and maintained a feasibility metric. I think the people and the experts involved, we could have built something that was a one-off that we were very proud of, but didn't act as a accelerant to the industry because we custom built a bunch of things. And that wouldn't have maintained the affordability, and it certainly wouldn't have made an example project that's intended for the Vision House as a compelling call for the industry to advance and adopt these principles and these standards. And that ultimately is the reason we're taking this cabin in the woods and making it an example for the industry, is because the people involved have the opportunity to take their expertise and to make it a part of the new standard for every home that's built going forward. And that is ultimately the intention of this home, is that although as we'll walk through the design and the characteristics and the topography, there's some unique challenges, this home, we intend to share the best practices in a way that it can inform a production builder in St. Louis, improve their practices and their processes to build better. Stace, any thoughts on our goals before we flip to the site?
Yeah, one quick thing is to say that we also very much want everyone to realize that this home will operate just like any other home. It is not going to be a system or a machine that needs to be continually modified by the occupants. It's going to work just like any other home on the block, even though it is off the grid. And that's important about keeping it simple and keeping it so that everybody can use the systems and designs that we are coming up with.
Excellent. So without further ado, here's the site. Here is the beginning of the challenge, and there's a reason I overlaid the topography. If you squint, the little light spot where there's a clearing in the lower center of these woods, this is a hill outside of Seattle in the Cascade Mountains, and it's accessed through a 2-mile forestry road, and this is the top of the hill, and this hill is 750 feet above the surrounding terrain, and as you can see by the topographic lines, falls very, very steeply. This is a little over 20 acres, and the net buildable area is about the footprint of the house. The rest of the acreage is beautiful timberland up above and east of Seattle. It provides amazing views, but accessing the site and building on the site was absolutely an intentional challenge and required us to really think through the materials to make sure that all the materials could be easily brought up and assembled on site with conventional labor forces, and that we weren't able to kind of leverage any unique crane construction because everything was going to have to be hand built, which is typical of obviously the conventional building practices of today. Stace, any other thoughts on the site and the challenges you had to think of before we get into your design?
No, I think we'll just go to the next slide and we can talk about what some of those challenges were and look at how the building integrates a little bit with the site.
Excellent.
So as everybody can see, as we were looking at the last slides, that we have a whole lot of forest, but we also have a good bit of topography change on this site. As CR said, it is the top of the hill, which is both, has pros and cons. I would say that the most important understanding that we did is trying to integrate this building into its site. So we tried to nestle the home into the clearing that was existing, but we also tried to integrate with the topography and nestle the home down into it, which we will look at a little bit later on. We obviously optimized the orientation of the building so that we harness all the great views and amazing views from up on the top of the hill. And being on top of the hill also has a great pro to it that our solar will always have direct access to the sun. So there's nothing that will be blocking it, nothing that comes in the future that could be blocking it, which sometimes when you're in the suburb is a big challenge. So again, pros and cons with the site, but overall a very dramatic and interesting site itself. Next slide, if you would, please. So this is the ground floor, and we're going to look at each level of the home and talk a little bit about the overall design. But before we get into that, I really wanted to go over the major concepts of this design. And the major concept along the lines of it being climate, site-specific and climate-driven is that it is a highly insulated envelope, that we very much went back to an indigenous type of design where they didn't have HVAC to heat and cool. We looked at the envelope of our house and said, if we keep it insulated really well and have a lot of thermal mass on the inside with high ceilings, we will reduce the need for any kind of outside heating and cooling to keep the home at a very comfortable temperature. This rolls into using your products and your materials efficiently. It then helps us with our energy efficiency. It helps us with our water efficiency. And it helps us to meet all the goals that we're trying to achieve. So I think that over the... Go ahead, Sierra.
Yeah, so one of the things I'm super excited about is the statement Stace just made around how we're leveraging the construction materials of this house. And it was one of the big goals that I had of this home, because we identified for almost 10 years now that energy efficiency is readily achievable with the technology that you can go into the US DOE Zero Energy Ready program or the EPA's program or Passive House, right? There's a great cookbook for energy efficiency, but load management is really the new frontier around energy efficiency. And so much of that load is controlled by heating and cooling diurnal swings that we wanted to build a structure that had isolated, insulated thermal mass. And the use of SIPs and ICFs and concrete flooring systems all tie together to create a tremendous resource for us to hold BTUs and intercept the gains and losses of BTUs in this envelope. And is a big piece of what we're going to be excited to share as we monitor this for the next several years, is to show how the thermal mass and the concepts from the 1920s, before the advent of air conditioning systems, we repurposed those high thermal mass design characteristics in a modern way to really make this home not subject to the diurnal swings and to have a much, much more consistent demand load, and still, once again, not require a lot of technology to manage those shifting temperatures, but passively achieved through design characteristics and material choice. Stace, this is yours.
As CR was saying, as we have a highly insulated envelope of ICFs, and we have a SIPS roof, which again are typical building materials found across the country that give us an extremely efficient envelope. Inside the highly efficient envelope, we have a lot of mass, including about a 34,000 gallon cistern. If we go back to a floor plan, would be great. Thank you. And we can note as we switch back and forth and seeing that site plan to this floor plan that the cistern and all of the mechanical equipment is nestled into the ground. So basically, it's like a walkout house. The walkout, instead of a downstairs den or a family room, is the two-car garage. The other three sides of the home are nestled down and coupled with the earth. And insulated walls bring us up. If we go to the next floor plan, please. We see that we have a very simple shape of a building, and its length and width is determined by the materials that it is being built of. So it is the module of an ICF block, and it has a width that spans of a Hambro floor system, which is joist with a concrete floor that can go across the dining room kitchen or across the living room, is the span that material can use as it is optimized. And that is how we came up with our width and length of this house. It is very simple to build, which means it's very efficient to build, and we're using our materials appropriately. The floors, both at this living room, dining room, kitchen, and bedroom downstairs, is a concrete floor. So again, it's a lot of mass that is isolated from the outside that helps the delta T, or the change in temperature on the inside, to be as little as possible. Again, we do not have to add a lot of energy and BTUs to heat or cool this house. As we go on to the second floor, we have the same thing. We have the Hambro system, which is concrete floors and steel joists. It is that system, the same as before, right span, built right on top of the one below it, the floor below it, making it, again, very, very efficient. In the middle of the home, where you can see the number 9, is a concrete or a masonry chimney envelope that goes all the way up. It is down in the basement next to the cistern, goes up through the first floor, goes up to the second floor, has a thermal break at the SIPs before it goes to the outside. And this is one of our good, simple design features that talks about capturing all the hot air that is at the apex, that is at the top of these bedrooms on the top floor, pulls that energy down through this chimney assembly of masonry, and then redistributes that heat down below. And it works just oppositely in the summer when we want to cool. We open up some exterior windows and it pulls all the air up and through and out the apex and super cools that chimney. So we're using it both in the heating and cooling cycles to keep the home at a stable temperature. And then natural airflow over the floors and along the exterior surfaces also add in to not having a big change in temperature from outside temperatures trying to come in. So if we go back down to the first floor, if we would please, we see that the first floor is pretty much the public space. It is a kitchen, dining room, living room, den, bedroom, like any other typical home. You'll note that on either side of the entry, which is number 1 and number 8, the living room, are our big view areas. And we'll note that in the other parts of the home, we don't have a lot of extra windows. We have windows to get some view out the sides, to see people coming up the driveway. We have windows to see an egress out of the bedrooms. But we really tried to concentrate where we put all of our exterior glazing and views and walkability, indoor out feeling in that main living space. So again, we kept the most economical and efficient exterior envelope that we could, while at the same time taking in all the great views. The next plan, if you would, please. So as we go up into the top floor, we have 2 master suites. And again, pretty typical home, just like any others. If you're looking at the elevations right now, you can see, again, it emphasizes that we really put our time and money into the building of that living room and entry area views that go to the great outside. You can look at the home, and it looks pretty much traditionally like any other home. It doesn't look like a solar machine or anything of that nature. It is a standard home that you could see anywhere in the United States of America. You'll notice on the image on the right, that is our PV canopy, and that is the walkout. You can see on the left-hand side stairs going up and the grade going up on the right-hand side, that we've nestled this home into this landscape. And you'll see on the slide on the left, we're talking about some great indoor-outdoor space. You can go to the next slide. Thank you. So as we look inside the home, again, looks like any traditional home whatsoever. On the left-hand side, you see a great kitchen, dining, and we see that we have some views out. On the right-hand side, you see the solar chimney that we are talking about. You can see that it is that masonry mass that we are using to keep the home at a stable temperature. And we're also using that as the mass to be able to move and use the heat that we're generating up at the top, or to exit that heat during the summertime as we need to. Next slide, please. Again, just some different views of the living room and the catwalk from the second floor that goes from master bedroom to master suite upstairs. On the left-hand side, we can see again, home is really nestled into its surroundings. And that's the chimney mass going up again. On this page, you can see that there in the master bedroom, we're talking about walls that separate the masters to the big outdoor space with some slats, some openings in them. So again, that we can allow the air to flow through all the upstairs spaces, be collected by the Panasonic system to be able and redistribute it through the space as we need to down through the chimney and out. CR, do you have anything that you'd like to add into that part of the conversation?
Yeah, let's wrap up on the design features and how we're utilizing the high thermal mass and the
sounds good
availability, and then we'll get into some of the challenges.
Okay, so you see the diagram that is in front of you of the section of the house. You can see the chimney there in the middle. You can see that at the apex, at the ridge of the design, you see that the hot air is collecting up there. The ability of being able to capture that hot air, force it down through that mass, and then redistribute it through the space through the Panasonic Cosmos system. And in the summer, we would be doing the direct opposite through the Panasonic exhaust fans that are in the master bedrooms and bathrooms. We'd be pulling in with some Panasonic Freshes, cool air from the outside, putting that into the chimney, pushing it down through the chimney and redistributing it on the first main floor. Again, using the natural convective loops of the home in both instances to our benefit.
So as you can see, the design and the intentions are to maximize the passive ability to heat and cool and to control the systems using the natural diurnal swings. One of the things that I love about this particular climate zone is we're able to look at the peak heat temperatures and recognize that on a diurnal basis, this part of the climate gets cool enough that we can actually avoid air conditioning. And so our system is designed to bring in that fresh air during the evening, store it through the thermal mass, use this Panasonic system intelligently, and then button the house up, build it very airtight, use that stored cool energy during the summertime to avoid the need for the mechanical system, the cost for that mechanical system, the cost to operate that mechanical system, by being thoughtful about the benefits of high thermal mass and the benefits of a very low ACH 50 home, and really establishing a new control system, this off-peak ventilation, to allow us to use the natural occurring diurnal shifts to minimize the external energy necessary to keep the home comfortable. And in doing all that, the home still will hold an even temperature set point and not require all that mechanical equipment and operating cost, and still keep the average occupant comfortable as though they had it. The pieces of all this, while being thoughtful, also mean that we're bringing to a municipality a new way of thinking about heating and cooling, a new way of thinking about ventilation, a new way of thinking about residential construction, that while it's got 100 years of proven effectiveness, it has been a challenge in bringing something new to a local municipality. This is in King County, which is where Seattle's at, one of the most progressive, high-growth markets in the U.S. And when you bring something new, it slows down the approval process. So we have, unfortunately, we intended to be halfway through construction by now, and we're still going through the engineering design review for sign-off with the municipality. And some of that is the challenges of the site. You can see how steep the slope is and the environmental conditions. This 20-acre site is designated as wildlife habitat, which we're maintaining as a part of this development. These slopes end up being considered critical areas, so we have to do a thoughtful engineering design and setback, and thoughts about forest fires, thoughts about erosion, thoughts about water runoff. And so there was a lot of challenges, but what I really appreciate about having this team is, as we establish and demonstrate this project, the intention is also to have a game book for municipalities that, as we implement these more sophisticated building practices, more sophisticated materials, these smarter control systems, that we can point to success stories like this home. We can point to permitted, constructed, and properly operating systems like this home is intended to be, to enable other municipalities to more rapidly move through this process. So we recognize that, you know, a good year of engineering and careful thought with the municipality, while it's a bunch of work for this particular project, it's intended to knock open those doors for all subsequent better building practices to really create this opportunity as a scalable project. We talked a lot about power, and I'm, you know, I think energy efficiency is something that's been the focus of the building industry for over a decade now. But one of the things that most people recognize that's undervalued is water, right? Because it has been cheap, it has been undervalued by consumers, and we have wasted a precious resource for hundreds of years in the U.S. and throughout the world because it has been a cheap and easy commodity. And knowing that in the very near future, with the drastic changes to climate, with the amount of residential construction that's happening in desert climates, and the amount of significant peak snowmelt and rains, followed by significant lack of precipitation in these changing climates, that we wanted to include in this design the thought about using all of our resources wisely, the materials that we build with to make sure that they're cradle to cradle sustainable, the energy efficiency to maximize the free available energy in diurnal swings, and to minimize the wasteful use of some of the conventional insulation and lighting and appliances. But this is a really interesting, and I hope to be, you know, new standard and change for the way we think about water use. So Stace, you had to do a ton of work to accommodate your design and engineering and architecture on this. So why don't you take a couple slides and walk through this new way to think about water use?
Happy to, CR. So I would say that I agree totally with CR. I think that the biggest single challenge that is coming upon us, not only as a country and as designers, but as the world, that water is our single biggest challenge that we've not focused on enough. About 10 years ago, we really started focusing on our water usage because we focused on energy forever, as CR was saying, and can get a home's utility bills down to $50 or $80 a month. That not a big issue, but we would have utility bills for water that were hundreds and hundreds of dollars, sometimes for big projects getting into the thousands of dollars. So we really started looking at water. How do we not just conserve that water, but I think the most important concept is how do we use that water as many times as possible before we put it back into the aquifer. That we don't want it to become runoff and becomes part of a problem, especially on a site like CR's Hill, where it is a natural area for wildlife. It is steep slope where we could cause all kinds of problems on the environment around us. So we designed a home where we captured all the roof water, and all the roof water goes down into a cistern. As you can see from your slide, almost a 35,000 gallon cistern, which means that we have all the water that we need and the water comes from the sky in this area of our country, that we can harvest it, and we get all the water we need for the entire year. We only, average 4 occupants only use about 140 gallons of water a day. So not only are we reducing energy consumption from having to pull this water out of a well, we didn't have to drill the well, which had gone through hundreds of feet of rock and been another degradation to the environment itself. But we're also not having to use chemicals to treat that water, where it's just not disruptive to the entire hydrologic cycle that's happening on this site. So again, we were blessed on this site with a lot of water coming from the sky. We're able to use that water that's coming from the roof and into the cistern. We're using it for landscape irrigation, as we have traditionally done in our homes for years, but we're also using this as all the potable water, all the water to flush the toilets, run the washing machine. And it is a very simple system with some simple backups, so that you always have security of having enough water for whatever your needs are. If we could go to the next slide, please. So the secure side of this, where we didn't exactly need this technology. This is an atmospheric generator that you're looking at on your screen, and basically it works like your refrigerator. It takes the air outside, pulls the moisture out of that air, condenses that moisture into a liquid, and puts that liquid into your cistern. There will only be a few times a year that this system may be used, but we really wanted to showcase this technology to bring it to be more readily apparent to everyone across the country. We've been using this product for about 8 or 10 years. This system in a hot, humid climate where you don't get rainfall all the time is a wonderful system to give you all the water that you need. This system right here will create about 150 gallons of water a day in a hotter and humid climate for about $8 or $10 worth of a day of electricity from your solar panels and being converted. So it's extremely efficient. We think that in this climate, this system should give us about 80 gallons a day, which, because we have such a large cistern, that we'll be able to add water in that cistern whenever we need to as it starts getting low, and turn this system on and off as it's needed to keep the cistern at the level that we want it, so that we know that we always have how many ever weeks worth of water that we need to have to use. This system only costs about $1,500, and it is very, very simple to maintain. Sarah, did you want to say something there?
Yeah, one of the things that I love about the environmental impact that Stace walked through is we're intercepting water that would have normally hit the floor plan, the footprint of this house. But we're intercepting it in a sustainable way where that water is the peak rain would be captured by the cistern, but that cistern is designed to hit maximum capacity and overflow. And that overflow be reintroduced back into the environment at a 1-to-1 ratio. And so through the house intercepting the stormwater and the home being able to consume some of it, but it also then exits through the water treatment septic system. And so at a 1-to-1 ratio, every drop that hits this house re-enters the environment at the exact same point, at the exact same aquifer, in a very appropriately engineered infiltration gallery, so that it reduces erosion, it reduces groundwater infiltration by taking out the peaks and grabbing it in the cistern, and it absolutely eliminates the hydrologic impact of this single-family home from this environment. And it's one of the things I'm really excited about, is that we're able to demonstrate a zero impact for off-grid electricity, but we're also able to demonstrate a very easy zero-impact hydrological cycle. And with this additional capacity to pull out atmospheric moisture, as Stace was indicating, we can take this philosophy and apply it to other climate zones and develop this best practice around water usage that really, to me, is inspirational, and I'm very excited about the ability to live in a wildlife habitat and not do anything that degrades, but actually adds to that habitat and that aquifer in a productive way.
And gives you water for 4 people to live on all the time.
Absolutely.
Pretty amazing. So again, that takes us on to the next piece, in looking at the energy side. So one of the challenging, as you can imagine, knowing the Pacific Northwest, is that we get some gray days. And the most challenging part about this part of the country is that you get those gray days when you actually need the most amount of energy to keep the home warm during those winter months. And so we sized the PV system for the 10 months of the year. That is the average use, which is about a 7 kW system to run and maintain this 3-bedroom home, which is a pretty typical size home. A 7 kW PV system is a very small system for an off-the-grid house. So we really have met our goals of being extremely energy efficient, and at the same time, we're able to provide all that power and going into a battery system that CR can look at and maintain and know exactly how much power he has, how many days of power he has. And the security side of this one is an LP generator. And that LP generator uses gas to turn into electricity to go into the battery system if and when on those couple months of the year that he needs more power. So again,
so I can throw a party and not have to worry about having my blenders run. It's nice.
Exactly. Like that, this home operates like any other home. There is no worries. It's not a machine where you say, "Oh, I can't do X because I don't have enough power or I don't have enough water," which is pretty cool. The other amazing part of this is the batteries that we're actually going to get to be able to use with this project. The battery industry, as many of you may know, is the most quickly technology improvement within off the grid and PV panels and solar energy. And we will be able to have our generator feed right into our batteries, which is a pretty new technology, do it very efficiently. So that is also something that we are very, very interested in monitoring and seeing how that works.
So I want to leave some time for some questions at the end. So I'll run through some of the major points that hopefully we've highlighted in this conversation, and have Stace give his thoughts on it. But one of the biggest things that I'm excited about is the opportunity to use technology and materials in storage to change peak energy demand, to change the conversation that's happening at the utility scale power distribution network that is literally worth over $1 trillion a year to reduce the peak to valley delta on a diurnal swing that utilities have to compensate for and have a very inefficient production and distribution network in order to meet these oscillating personal demands. And so, a lot of the things that we'll be talking about and demonstrating and following up on will be how these smart controls, how these materials, how lifestyle intersects all of these things to create opportunities to make a house that maintains comfort, that's easy to use, but drastically upstream improves the energy load factor and creates a tremendous amount of value, especially for the utility companies that, as they're responding to increase in energy efficiency and these duck curves from solar energy, need an opportunity to align their business cases with the evolution of sustainable homes. Stace, thoughts about all the great materials you're using?
Yeah, I'm going to go right back to the power just for a minute. Is that the battery systems in this house and the smart battery system that it's going to be is going to really change the way in which our country manages power and when that power is used. By being able to offset that peak demand use by having these batteries in the house, there is thoughts and discussion within the industry that those batteries could be somehow managed somewhat by the utility company to trigger them as to when to offset and put power into the grid or use the power for that specific home itself. Thus, really shifting when that power is needed so that we don't have these huge surges of when electricity is needed. Think of the impact that would have had in California during these fires and the high heats where the utility companies were just having to turn power off because they were hitting these peak demands at the wrong time and the wrong temperature. And if we could control and have a system that works that efficiently, would be really, really cool. Next slide, please. So I think that the biggest thing that we are looking at, and we're talking about climate change and how our products and everything look at this, I think that one of the most important ones that we are trying to work on, and the industry is just stepping in to this realm as the last couple of years of a lot of forest fires, and that is that we have a totally non-combustible house. We are not building out of wood. We are building out of concrete. We do have some SIPS roof, but it is a Class A roof, the way that it is protected. That we have some great boral exterior siding. We have a boral roof that gives us a metal roof so that it looks like a typical home, but it is much more resilient to temperatures outside. We are working with Uponor and some other people within the industry of saying that, gee, we have a 34,000 gallon cistern. Could I not have some kind of a fire suppression sprinkler system on the outside of my house where if I wanted to, I could turn it on and wet and cool the exterior of my house and the 5 or so feet or 10 feet around it? We obviously have a home that has the ability to withstand any kind of storms and things coming to it. It should be said that we could get some pretty big winds that CR has experienced in person up on the top of this hill, so that we are building this home to be able to withstand big surges in wind. And we are also making this home to be able to withstand earthquakes. So we're not only looking at fire, but we're looking at earthquakes. We are looking at big winds. We're trying to make this home as durable as possible. Because of the cistern system and everything that we're doing, we're also looking at the external drainage planes and harvesting all that water, getting it down to the cistern, but also making sure that we have a smart design that doesn't allow water to penetrate into the system and erode the long-term durability of the home. Because we want this home to be able to last for hundreds of years, not decades. This is actually one of the most exciting components of everything that we're doing. For years, I was one of those architects who, used all kinds of little data loggers, and I was climbing in ceilings and crawl spaces and trying to understand how the HVA systems or whatever system in the house, how much electricity it was using. We're trying to gather information so that we could make better design decisions. What excites me so much about this house is to have real-time data, to be able to have that data systems, to be able to collect information in the home. So when we're having some kind of an extreme event, it got a lot colder than we ever thought it was going to in this zone, or it got a lot hotter than we thought it was going to. What's happening in the interstitial spaces? How well is our thermal chimney idea working? Is there certain times and temperatures or something happening outside that the system had to turn off, or was bringing in air that we didn't think that was the proper temperature or something of that nature? I am super excited about Control4's system because it's an open platform system. Most all of our vendors and suppliers are buying into that with sharing technology and figuring out how to make it work. And we should really be able to understand where and how the energy is being used in this home. We should really be able to understand how it operates. And we really will understand what are the different parts and pieces that are maybe keeping us from being net zero, or that are just such big energy usage, maybe we don't want to use them. So again, a lot of great information.
And, the use of data for me has become really important as we look at the level of expertise and the subject matter expertise that we're able to bring into this project that I'm so excited about, is because, as we see, as an example, Boral Steel has developed this new stone-coated roofing. And if you look at the building science underneath it, that steel structure does not sit on the roof and creates air movement, which will create natural conductivity on warm days that will act to ventilate between the roof and the SIPs. And so instead of having direct solar radiation impacting into the SIPs and counting on the slowing of that energy movement, we actually get BTUs being removed during the daytime through this natural ventilation. And in order for us to take credit for that, we're going to need to have energy monitoring to be able to develop an algorithm to be able to demonstrate how this roof acts in a unique way, like a cool roof. And the leveraging of thermal mass and the use of smart ventilation with Panasonic, and the use of energy and the repurposing of excess energy when the batteries are stored but there's still sun out, and all of the opportunities to really look at an example of the materials and the controls and the iterative process of using data is a wonderful opportunity given the group that we're involved in, but also just the use of materials, right? The the mountains in the Cascade region in this group experiences a tremendous amount of weather. And so, with moisture shield and with western window systems and, with our cladding systems and our roofing systems, we have such a great opportunity to really throw nature at this house in a thoughtful way, but having a design that's intended to minimize its impact. And as Stace had said, the intention of this house from my concept all the way through has been, this house will pass the test of time and become something that, becomes an asset to future generations, both as in its function, but also in maintaining its form.
I just would like to also add in here that how excited I am that all the team members working together at trying to bring this project to its greatest and highest potential, understanding what roadblocks are in our way and trying to understand how to get around those roadblocks so that we can achieve our goals, because that's a whole lot about how we make it simpler and more intuitive to not only build, but to maintain and operate this home.
Absolutely. And so with the last couple minutes we have left, if anybody has any questions that this overview has inspired that we didn't answer, please just type a message in and Sarah will receive it and relay it on to Stace and I, and we can certainly answer that on this WebEx. And if we run out of time or there's questions that come in after we close this WebEx, we certainly will respond back through our media channels. So let me end on just the overview of where we started, right? The intention of this Vision House is to put together something that creates substantive value, that uses materials and thinks about total cost of operation and maintenance and resiliency in a way that inspires the industry to develop tools and incorporate them into conventional construction to improve the durability, the comfort, the resiliency, the efficiency, and the use of natural materials in this home. It's something that I'm super excited to host. Anybody who's interested, come and seeing it as we go through. I'm super excited to build it and to tell the story. And more importantly, I'm super excited that the lessons that all of us develop together here can be used to improve the built environment and the processes and the energy modeling and the thoughts that go into designing our future. Stace?
Just wanted to say thank you very much. I am super excited about building this project and working with everybody. I think that from this project, we are really going to be able to understand how we can all move forward and really inspire people, not only just the industry and everything, but homeowners. This is simple. This is achievable. It understands for homeowners how they can be part of the process to fix things and to really make a positive change in our environment.
CR and Stace, thank you so much for, well, first of all, your thoughtful approach to this project. This Vision House Seattle Cascades is going to be exceptional because of all of that thoughtfulness and the brain trust that has gone into it by you, by our sponsors, by our general contractor, Ted Clifton, and by our other project partners. I have a question here from one of our viewers, and I actually encourage everyone else who's still on the webinar to please type in any questions that you have into the questions box on the WebEx dashboard. And Stace and CR, if you have just another 5 minutes, we can just go through a couple of questions. But the first one that I've selected here is about this concept of full cost versus upfront cost, which I know is a big topic that we're trying to address head on with respect to the Vision House Seattle Cascades, and really looking at shifting the price per square foot valuation metric towards something that incorporates sustainability, quality, durability, resiliency, all the things that we're trying to encompass with this project. But this specific question has to do with the fact that in order to achieve that goal, we're really going to have to make an impact in the financial and mortgage sector as well as in the insurance sector. So, CR, can you talk a little bit about, how this project or the concept of this project at this point is being received by the financial and insurance sectors?
Yeah, so the concept is that if you spend $5 more in better materials and that increases your mortgage, each month, that the savings from reduced maintenance, the savings from reduced utility costs offsets that investment, and that there is a financial return on investment for building better that the mortgage company doesn't currently think of. And there's several initiatives in order to change that. One is simply using the savings that are modeled in an energy efficiency score like a Herro score to improve the underwriting characteristics of a mortgage. And so a good example of that, there's a piece of legislation called the SAVE Act, Sensible Active Value Energy, that would compel all federally underwritten mortgages to include those savings in the underwriting process. And what I'd be super excited about in that process is that those policies would not only allow you to invest in building better homes, but would also create the opportunity for people to implement cost-effective, ROI-positive improvements to existing infrastructures, because now they have a mortgage partner that they could leverage that savings into their mortgage. So if anybody's interested in that particular piece of legislation, go to imt.org. And then the MLS is also adopting increased content in the MLS so that buyers can identify third-party certification, can identify ERI scores or Herro scores or some other sort of predictive energy saving scores, so that they can sort their searches for more thoughtfully designed homes with lower operating costs. And so through that partnership of realtors and underwriters, the last piece is the appraisal process. And for the last several years, there has been an addendum called the Energy Efficient Addendum. It's AI 820.04. And that is an addendum which allows appraisers to capture the better windows and the better insulation and the higher CR HVAC and the solar panels and all these other components to increase the perceived value, increase the actual value above the comp analysis. So when they're comparing the selling price of a 2,400 square foot home that doesn't include those features, it would allow, that addendum allows them to add the value of those features on top of that comp analysis so that it appraises right. And that's the magic three, right? If we can get the consumer awareness and the realtor awareness to the MLS, if we can get the appraisal process to value the better features appropriately in the appraisal, and the banks to either adopt the appraisal and or improve the underwriting to value the reduced monthly operating cost of a well-built, durable home with energy efficiency, the market will change because we've now monetized all these benefits in a very apples and apples way.
Sir, I could take on the insurance real quick also, that we're actually making good headway with insurance companies. This obviously all started in hurricane zones and flooding, but now insurance companies through the Insurance Institute for Business and Home Safety are understanding that this affects all kinds of extreme weather. And IBHS studies show that homes and businesses fortified by stronger building materials and construction practices are more likely to survive extreme weather events that otherwise would have severely damaged or destroyed them. So we are slowly seeing a shift in the insurance coverages and system itself, that if you meet these fortified standards, and we're having to help develop these fortified standards, that they are lowering monthly insurance costs. So, but that's a slow change industry right there, obviously, but extremely important.
Wonderful. Well, CR and Stace, thank you both so much for your time today. I also thank all of you who joined us for this webinar. Please continue to track the the progress of the Vision House Seattle Cascades through our microsite, which is listed here on this slide. And if you have not yet signed up for our Vantage e-newsletter, please go to our website at greenbuildermedia.com. We will have regular coverage of the Vision House Seattle Cascades, as well as in Green Builder magazine, which we also encourage you to subscribe for either digitally or the print version. So again, thanks to CR and Stace. Thank you to our wonderful project partners and sponsors, and take care. We'll see you next time.